Let's take a look at the Digilant PMOD BT2 based on the Roving Networks RN42 Bluetooth module. We'll take a look at the features and pinouts of the module, and then learn how to use this module for a cable replacement application. This is the module that is included in the NI MyRio Embedded Systems Kit. It's the Digilant PMOD BT2. It's based on the Roving Networks RN42 data module. Roving Networks was acquired by Microchip in April 2012. For that reason, you will find all of the information that you need in terms of data sheets, application notes, and command reference at the Microchip website. There's a number of applications for this Bluetooth module, including wireless data link, serial data cable replacement, that is, it appears as a COM port on a PC and as a UART to the mobile appliance, such as MyRio. The RN42 features a fully qualified Bluetooth version 2.1 module supporting serial port profile and dial-up networking profiles. Sustained data rate available is 240 kilobits per second. It sports an integrated antenna that gives you a range of up to about 20 meters or 60 feet. Bluetooth communicates over 2.4 gigahertz. The UART output supports 1200 baud up to 921 kilobaud, with 115.2 kilobaud as the default. The supply voltage is 3.0 volts up to 3.6 volts, with 3.3 volts considered typical. Now, the PMOD BT2 board has a number of features as well, including mode select jumpers, as well as a pair of status LEDs. Those are located right here. In particular, LED D1, which is the green LED, has a number of blink codes. A slow speed blink means that the module is discoverable and waiting to connect. Medium means the same thing, but also indicates that the module is able to accept a command mode request. Fast blink rate tells you that you are in command mode, and this is when you can configure the device. And when the LED is off, that tells you that the module is connected. That is, the data link is active. Let's take a look at the pinout of the PMOD BT2 board. This is J1 connector. I'm going to look at it face on. This is the top of the connector right here. 12 pins altogether, numbered like this. Power and ground located over here. Pins 6 and 12 connect to 3.3 volts, and pins 5 and 11 are ground. Here's the UART receive and transmit lines. Just to clarify, TX is an output from the RN42. Pin 7 is the status indicator. A high level tells you that the module is connected. Pin 8 is the reset. This is an active low signal. It is pulled high on the PMOD BT2 board. That tells you that you could leave it disconnected if you choose not to use the reset feature. It's the same as power cycling the module when you drop this line low. The remaining pins are RTS and CTS. Pins 9 and 10 are no connects. RTS and CTS are flow control signals. A brief bit of history here. DTE stands for Data Terminal Equipment. DCE stands for Data Communication Equipment. Originally, a DTE was a teletype, and a DCE was a telephone modem. Now, the first flow control signal, called RTS for request to send, would be activated when the DTE is requesting the DCE to receive data. CTS would be a feedback signal, clear to send, that says that the DCE is ready to receive data from the DTE. Now, these were the original definitions for RTS and CTS signals. In a more contemporary definition, RTS active means the DTE is ready to receive data from the DCE. Also, DCE now refers to data circuit terminating equipment. For example, the MyRio would be DCE, and the RN42 would be DTE in this context. Both of these signals are active low. What does all this mean for your program on the MyRio? Well, if you see the RTS is high, you need to stop sending data to the RN42. In a similar fashion, if you need the RN42 to stop sending you data, then you should raise CTS high. Now, CTS is pulled low on the PMOD BT2. That means inactive. Therefore, you can go ahead and leave this disconnected when your MyRio application is fast enough to not miss any data. Now I'd like to walk you through the details of a cable replacement application featuring the PMOD BT2. Imagine a vintage PC talking to NI MyRio using a serial data cable. The UART would be visible on this familiar legacy port, a 9-pin D-sub connector. The UART would then appear to the application software or terminal emulator software as a serial communications port, also known as a COM port. Now jump forward in time to the present day where we have a modern PC that includes a Bluetooth radio. We would like our application software on the PC to be able to communicate with the application software on the MyRio, and that's where the RN42 module comes into play. The RN42 establishes a wireless data link between the PC and itself, and then you have the same wired interface between a pair of UARTs on the other side of the RN42. When the RN42 is using its default serial port profile, it appears as a virtual COM port to the application software and terminal emulator software running on the modern PC. I'd like to show you how you can pair the RN42 with a Bluetooth-capable computer such as a laptop computer. Here I'm running Windows 7, but the process is similar for Mac OS as well. So I'm clicking Add a Device. I already have the RN42 powered up, and we see RN42 and the last 4 characters of the Bluetooth module MAC address. Enter the device pairing code, and by default this is simply 1234. Might take a little bit longer than what's pictured right here. I skipped over some of the setup time. See a little message about installing and configuring the driver and so on, and eventually we see that it has been successfully added as a Bluetooth device. I'll come back to Bluetooth again, show Bluetooth devices. Go ahead and double click on that, and we have, especially under hardware, you can see that the virtual COM port is COM5. Services available are serial port profile, again on COM5. You may very well end up with a different number when you pair your own RN42. You'll want to check that and make note of it for future reference. Let's look at the LabVIEW VISA, or Virtual Instrument Software Architecture, for interacting with the UART on the MyRio. This palette is located under the MyRio Advanced I/O and then UART subpalette. You have Configure. You can check the number of bytes at the port. You can read and write bytes through the UART, and you can close the port when you're all done. There's some other options that are available as well. Now back on the PC side, you can create a LabVIEW desktop application that also communicates with the COM port using the same exact interface. The palette's located in a little bit different place though. It's located under Data Communication, Protocols, and then Serial. There's a number of very nice terminal emulators out there, and in particular I recommend this one called PuTTY. It's available at putty.org. Now here I have a project put together where I have on the desktop a LabVIEW application called Main Desktop, and then I have also an application targeting the MyRio. Open that one up first. This displays incoming characters. It also shows the status and RTS lines from the module, and then you can reset the module from this panel as well. Here we see the VISA configure serial port. You can specify the desired MXP connector. Here's the setup that's appropriate for the RN42. Inside the main loop, I'm waiting for characters to become available. reading those characters and then echoing those back as an option, and then manipulating the LEDs on board the MyRio in response. After that loop exits, I'm closing the serial port. This parallel loop manages the reset and CTS pins and also monitors the status and RTS pins. Go ahead and run this application. So again, just a reminder, this is code that's running on the MyRio at this point. Now let me open up the desktop application running on my own laptop computer. Now the COM port number can change. In this case, I had paired the RN42 at a later time and came up with COM7. Very similar in terms of configuring the COM port. And inside the main loop, I'm transmitting the loop index as a single byte value and doing this once every 500 milliseconds. I'm also checking to see if any characters are available coming back from the MyRio. I'm going to go ahead and minimize the Project Explorer window and then start running the VI on the desktop. See the character code starts to ascend from 0. That's the transmitted character. And you'll notice that via the RN42, these characters are being received at the MyRio side. Status is active, telling us that we have an active data link. I'm going to enable the character echo, and now we see the characters being transmitted from MyRio back to the desktop. All right, let's try one of these flow control signals. This is CTS. I'm going to activate this, and this suspends the data transfer from the RN42. Notice that it's paused, and when I release CTS, notice that the buffered data appears in quick succession. Now I'm going to go ahead and stop the desktop VI, and remember that closes the COM port at the end. When that COM port is closed, we see that the data link is broken and status goes inactive. Now let's try the PuTTY terminal emulator. I already have a configuration set up for Bluetooth. It's the appropriate COM port, baud rate, and flow control is set to none. Let's go ahead and minimize that one and then open up the terminal window. If you look carefully, we see that the status LED has just gone active again, telling us that we have an active data link established. I'm going to try typing some characters. Now I don't see anything in the window, but if you look over here at the incoming character zone, try typing some more characters. Sure enough, they are getting transmitted across to MyRio. Let me enable the echoing of those characters. And now what's happening is the character goes out to MyRio and then is immediately bounced back and received. I'm going to try to enter the command mode for the RN42, and that's done with $3 in a row. I have to reset the module in order to restart the 60-second configuration time window. I'll have to close down PuTTY and restart, and this is where it's handy to have already saved away a profile that you can just load and go. Looks like I need just a little bit more time. Let me try that one more time. Again, here I'm just double clicking on my profile. I'm going to control and then right click to access the PuTTY options. In particular, I'm going to be turning on the local echo. So at this point, when we see commands such as the $3 that's from the local echo. CMD tells us that we are now in command mode. You can press H followed by carriage return for help. See what kind of things we have here. Variety of set commands. All sorts of things can be configured on the RN42. For example, you could get something other than the default 1, 2, 3, 4 pairing code. Or if you want, you could change the name. The default profile at the moment is SPP, but there's some other profiles that you could look at. You can also display basic and extended settings. D and E are the commands for that. You can also show the firmware version. That would be with a V. Let's give that a try. So type V, hit enter, and it tells us that we're at version 4.77. You can exit the command mode by typing 3 hyphens in a row. Now I hope at this point you have a much better feel for how you can do a wireless data link between a desktop computer and your MyRio using the PMOD BT2.